This is part 2 of the pH-pOH video. I'm just going to start talking a little bit about what pOH actually is. I introduced it in the first video with some calculations, but didn't really tell you what it was. So the pH scale is a scale for large changes. It's a log scale, which means it goes up in place values of 10. So step 1 on the scale would be 10, and step 2 on the scale would be 100, and 3 on the scale would be 1,000, etc. Okay, the negative in our log scale here is because our molarity numbers are generally decimals, so we need to put a negative in front or our pHs will come out negative. And it's important that when you put your negative in, if you are doing anti-log or shift log on your calculator, that your negative go right up here in the exponent with the x. Okay, you do not want to put your negative down here in the front. Okay, that's not the right spot for it, so you definitely don't want to accidentally put your negative there. Your negative has to go up in here in the exponent, same with in pOH. So, I will introduce where pOH came from. I wrote these notes out for you so you didn't have to spend time copying them in. The pOH scale measures OH. The pH scale measures H3O. Most of us have learned the pH scale since grade 10. It is the one that most things will default to. The pOH scale is like a reverse of the pH. So, pOH of 0 to 6.9 is basic. The important thing is that pOH plus pH there equals 14. So if you have a pH of 11, you will have a pOH of 3. So very easy to convert between the two. A good rule of thumb is if the question gives you OH and asks for pOH, you have one step. So you can just do simply pOH equals negative log OH minus. However, if your question gives you H3O and asks for pOH, then you're going to have to do two steps. So in your first step, you are going to do pH equals negative log H3O. The reason you're going to do that is because the question gave you H3O. You have to start with what the question gives you and convert after. And then in your second step, you would do pOH is 14 minus the pH. The pH scale is meant for usual use between 0 and 14, but there are some exceptions. For example, if I calculate with 10 molar H3O, that's a very strong acid, it will turn out to be a pH of negative 1. Okay, so sometimes you will see a negative 1 on the pH scale. Okay. Conversely, we could talk about a pH of 15, but this is better handled as an OH minus or a pOH of negative 1. So if you're having like a scale that's going to 15 for pH, it's usually called a pOH of minus 1. Those ones rarely occur in your regular calculations. I just thought it worth mentioning them. We'll move on to some more practice calculations with pH. So example number 1 asks you to find the pOH of 0.2 grams of NaOH. So we're already working in a base here, which means I already have OH minus, so I can go straight to pOH. So first thing I need to know is what is my molarity. So we need molarity of NaOH. So we're just going to review a grade 11 calculation here. Molarity is moles over liters. Okay, and I had 0.2 grams times 1 mole. The mass for NaOH is 40 grams. Use your periodic table, so 40.0 grams. That's my first step. That's grams to mole. And then divided by 1 over 0.5 liters. You could also do the 0.5 liter step at the beginning of the equation. So 0.01 molar is now my pH of, or sorry, not my pH, this is now my NaOH concentration. Okay, the next step, I'll keep it in blue, is to find my pOH. So I'm doing pOH equals negative log OH minus. My molarity for NaOH is 1 to 1, so I can simply use my number because this is a strong base. Bottom 2 on the table, and it's columns 1 and 2 from your periodic table. So sodium, being an alkali metal, is column 1. And if I work that out, I can get a pH of 2. I'm just skipping sig figs in this, but it looks to me like we have a 1 sig fig number, so 2.0 would be one significant figure. What's the pOH? This is going to be 12 or 12.0 because the 2 must add to 14. Our next question asks us about neutral water. Oops, it says at a certain temperature. Just need to fill that back in. Neutral water has a pH of 7.791. Okay, so we're not using 25 anymore. Here it says at a certain temperature, so which means our pH is no longer going to work out to exactly 14. So we've got a different number here. They want to know the Kw and the OH minus at this temperature. So first of all, we need to talk about the clue that's given. The clue is that it's neutral water. And the reason that is important to you is it tells you that your H3O plus is going to be equal to your concentration of OH minus. Okay, another way to phrase that in a question is pure water. So those two words, neutral or pure, are your clues that your H3O is equal to your OH minus. Okay, so first thing we can do is we know our pH, so we can find our H3O. So pH is going on the opposite side of the equal sign. Oops, sorry, that should be 0.1. From my log, which means on my calculator, I'm going to have to do antilog. Or when I put this into my calculator, it's going to be 10 to the negative x, or 10 to the negative 7.791. And that's going to equal my concentration of H3O plus. So if I work that out, I'm going to get 1.62 times 10 to the negative 8, which is my H3O plus. And it is also going to be my OH minus because we know those are equal because it's pure water. The second piece of our question, I'm just going to switch to a different color here, so that's this part here gave us our first answer, and now we need to solve for Kw. So Kw is H3O plus times OH minus. Okay, and we know that both of those numbers will be 1.62 times 10 to the minus 8, so you can just do squared or you can type them both in. So my new Kw is going to be 2.62 times 10 to the minus 16. Okay, and I'm just going to make a note that this is smaller than our regular Kw, which we need to know that for our next piece of our question. Our next piece of the question asks you, is the water hotter or colder? So in order to do this, we need to remember that the ionization of water is endothermic, which means that our heat term is on the reactant side of the arrow. So here's an equation that I can use to apply my Le Chatelier's principle to. Now, I do not know if I am heating or cooling, so I'm not sure which way this is going to go, but I do know that I have a smaller Kw. I found that out in the previous question, which means I'm getting product light from our previous discussions on equilibrium. So I'm getting product light, I know I'm shifting this way. So if I go back to Le Chatelier's principle, if I'm shifting toward the heat term, it means my heat term was moving downward or it was too cold. So this is colder than 25 degrees. Okay, and then my last one, I've done the example for you. I'd like you to try it on your own and pause the video and then scroll through to the answers, and I'll give you some hints here. So it says assume a system not at 25, so same kind of question. Involves a sample of pure water, so there's our hint again, our pure or our neutral. I'll get a brighter color here. That's important. But it's boiling, which means we know it's going to be warmer. So to start with, I am going to do Le Chatelier. So I'm going to increase my temperature, and I'm going to shift this way. So I've written here that I have more H3O or I'm product heavy. So what's going to happen to the pH of the water? The H3O is going to tell me I'm going to have a lower pH. Now, this is the important part. What happens to the pOH? We need to remember that it was pure. So the H3O is going to equal the OH minus, which means my pOH is also lower. So there's more OH ions as well as H3O ions. And what will happen to the value of pKw? So pKw is something you haven't seen before, but P means negative log of everything, and kW, and you know kW is 1.00 times 10 to the minus 14. So when you work that out, you're usually expecting to get an answer of 14. However, we are not at 25 degrees. So 14 would be if this question was at 25. So I put in light blue here in a different answer because we didn't have numbers to work with for our pH, so I've given you a hypothetical example. So in question A, the answer is the pH is lower. So lower means lower than 7, because 7 would be neutral. So we're going to say it's 6.7. So in part B, that means our pOH would also be 6.7. And if I was going to add the two together to make pH plus P4OH, it's going to be 13.4, which is not 14, because our water is not at 0. Okay, so when the question asks me what happened to my value of pKw, it also decreases. That's one of the more difficult concepts of pH, and I can address that in our tutorial next time.